we want to use cylindrical coordinates to evaluate this integral. So basically that means we want to change the x and y integral to polar coordinates and leave the z integral as it is, but just write it in terms of polar coordinates, in terms of the new polar coordinates. Okay, so one thing that you should probably try to do is get an idea of what this region is that we're looking at. So if we look at the xy integral, though that's not completely necessary if you understand what's going on, though you could make mistakes if you don't. So if you look in the xy plane, if you look at the xy integral, x goes from minus 2 to 2, and y goes from minus the square root of 4 minus x squared to plus the square root of 4 minus x squared. So minus the square root of 4 minus x squared is the bottom part of a circle of radius 2 centered at the origin. The square root of 4 minus x squared is the top part of that circle. So again, this is a very bad circle, but this is a circle of radius 2 in the xy plane. Now z, this is a little less important, I think, for this problem, but z is going to go from the square root of x squared plus y squared to 2. So this is like the inside of a cone. So remember, z equals the square root of x squared plus y squared is just the standard cone, and z is going to go from a point on the a point on the cone to z is equal to 2. Okay, so this is just integrating over a cone. All right, so in polar coordinates, z is going to go from the square root of x squared plus y squared, that is r, to 2. And now the xy integral, we're going to change this to polar coordinates, so it'll be in terms of r and theta. R will go from 0 to 2 because it's a radius 2 circle, and it's the whole circle. It's not just a quarter or half of the circle. So theta is going to go from 0 to 2 pi. X squared plus y squared is r squared, and then we have the r from the polar coordinate transformation, dz, dr, d theta. So this r right here, that's just the r from the dr d theta. And that's it for this problem. We switched it to polar coordinate or to cylindrical coordinates, and now this is an integral that you can solve, compute on your own.